Okay, so indeed there was a problem with the graph here. A red line هو للFE 2 plus. Green line is for the FE 3 plus concentration. هلا the combination of both FE and FE3 plus, FE2 and FE3 plus هو 1 molar. بمعنى إذا الgreen is 0 when the potential is low, the green is 0 and it's 1 molar of at Fe minus Fe2 plus. يعني عندنا 1 molar starting here. We start on the Fe and then we're going backwards. Okay, that's how the reaction is really starting. We're starting at 0 Fe3 plus and at 1 molar Fe2 plus. Fe2 plus starts to decrease, Fe3 plus starts to increase in concentration. When they're equal to each other, we have the E naught value. We reached the standard reduction potential. As my Fe3 plus becomes greater, yani on top, as a concentration, as it becomes bigger, the upper part is greater. That means the E is greater than the E naught. When the Fe is bigger, this becomes negative, and that means the E is lower than the E naught. Okay. Now we're going to continue with part 8. Same recording. pH measurements from E. Define apparent standard potential. Derivation of this actually is easy if you follow step by step with me. A lot of reduction or oxidation half reactions depend on H3O plus or OH minus, and therefore depend على pH. So we have half reactions that are balanced in acid or in base. We're looking at a half reaction here, which has already H3O plus as a reactant, and this is a reduction half reaction. The Nernst equation, and we've seen this already, of this half reaction will be the E naught for the half reaction plus 0.0592 على N log reactants على products or oxidant على reductant, and not to forget the H3O plus to its stoichiometric ratio, okay, or coefficient. Now the pH. Okay, what I want you to do is go back here. If I take this log and split these two terms, so it becomes log ox على red to its stoichiometric coefficients plus log of H3O plus to the power m. So I split those two half reactions. Log مع الأوكس red will log value to the H3O plus to the power m, but I took the m outside. Of course, before the log value, there's still the 0.592, and that remains. Clear? Should be. Now, log of H3O plus is simply minus pH, يعني محلها بحط minus pH. This term remains the same. All right. Now, this whole thing, E naught minus 0.0592 m divided by n pH. مطرحها هقول this is E prime 0, or we're going to call it the apparent standard potential. Why am I doing that? So we're going to call this the E naught minus 0.0592 E prime naught. If I substitute then for this guy, the E prime naught, we get E equals E prime naught plus 0.0592 log ox على red. This reminds me of the normal Nernst equation, بس بدل E naught سميناها E prime naught. And they're calling this the apparent standard potential because this is not really the standard. This is the standard potential, but corrected for a pH term for the effect of acidity on the reaction. So the E prime naught is the E standard corrected for the acidity. The correction value is minus 0.592. The stoichiometry on the H3O plus divided by the number of electron transferred times the pH of the system. Okay. As pH increases, if I look at this, if I increase pH, what happens to this E naught, E prime relative to E? كل ما I increase pH, I'm decreasing the E naught, and this is going to become more negative. And so E prime naught decreases. As pH increases, كبرتها, pH is bigger, then the overall reduction potential of the couple decreases. If so E naught prime, that's it, decreases. And the overall reduction potential of the couple decreases. That when the E naught decreases, the overall E also decreases. That means the reduction potential decreases. The oxidizing power of the ox decreases, while the reducing power of the red increases. كمان كلمة خلاص reduction potential decreases, that means كمان that the oxidizing power decreases. It becomes less of an oxidant. I don't need you to worry about these, and I'm not going to really discuss them. The idea, but when the apparent potential equals للpotential, that means ما عندنا effect للpH, no pH effect. Okay. When the apparent potential is less than the normal potential, okay, that means that the oxidant predominates, or if it's less than, then the reductant predominates. How did they know that? That the oxidant concentration predominates or the reductant predominates? If I go back, literally, and I put here different pH values, less or greater. In other words, or put a number here, bigger or greater. بعرف إذا عندي ox is greater than red or red is less than the ox. That's how it's done. Or I draw a diagram. And here's the diagram. The diagram is for just the effect of the pH. So نحن شو قلنا؟ خليني بس حط الإيكويشن. قلنا apparent potential is E naught minus 0.0592 M على N pH. فكروا بهيدا as if he is a Y equals BMX diagram. So here, the Y-axis is, the X-axis is the pH. That's the X-axis, pH. And we'll have the Y-axis as the E prime E naught prime. Okay, E naught prime on the Y. E naught prime equals للE أي متى when the pH is actually 0. And if it pH is 0 here, then E naught equals للE. So we start at pH 0. That's when E naught equals لE prime. And then as the pH increases, put higher pH here, put a higher pH. As my pH increases, you're going to see that this diagram, this is going to go downwards because the slope is negative. This part, this end is the slope. This is the M. It's negative. So it's going to go down. And we see that as I go down, there's a particular pH value. We call it pHi. pHi is the value where I either have equal concentration ox على red. That's when أصلا if ox equals the red, then I only have E prime equals the E naught right there. Okay, so if ox على red, that means خلصت. لاحظوا نرجع للإيكويشن. If ox equals the red, this term كلها بتروح يعني الإي بتصير خلص E prime node لأن هيدي كلها سميناها E prime node. That result, you memorize for yourself that they are equal to each other, the E naught and the E prime, then that means we have no effective pH. When we have the E naught here is greater than the E, always the oxidizing agent predominates in the solution. And at the lower end, if the E naught is the E prime, it's a E prime greater than E naught, again, the oxidant should predominate, and is a less than, then the reductant should predominate. Again, عندنا نفس الغلطة. Okay. What? These will never be asked directly like that, who predominates. أصلاً you will find the exact concentration at a different pH. That's how the questions are asked. They give you different pH values, and they will ask you, you never use the standard. You will use this overall equation, or actually the start, or حتى ولا وحدة من هول. You will use this one, the normal nurse, which has H+. At different pH values, you could always calculate the ratio of ox على red, or here. At different values of H3O+ and different pH values, you can get always this term by itself. So you can always see for yourself if you have more oxidant or more reductant.
Doctor, do we solve for E prime 0?
Do you solve for E prime 0? Do they want the E prime 0? Sometimes they ask questions if E prime is greater than E or not. يعني what happens to the overall potential. يعني إذا ال E prime greater than E، يعني هيدا الفاليو رقم صار أكبر من ما كان. That means the overall potential, reduction potential, increases. see certain questions بالpreviouses. Questions though are direct يعني مش هالقد complicated. أكتر بيسألوا على pH. What happens if I increase pH? What will happen to the potential of the reduction potential? So what you would say, I recommend you memorize this and actually this whole nurse corrected with a pH. If my pH increases, لاحظوا, this term becomes more negative, and that means that the E becomes less. So the reduction potential decreases. So increasing pH decrease the reduction potential. It also increases pH, also decreases the E. It decreases reduction potential because it decreases the apparent standard potential. Yes? As my pH increases, this apparent potential decreases, and when this apparent potential decreases, then the E decreases. Don't worry too much about it till we solve some questions, but worry about the derivation. I do want you to go through the derivation a little bit to make sure that you understand how I'm deriving it, لأنه كمان بالtitration بتكون شوي مهمة لإلي هيدي. نفس الفكرة, same type of derivation. We conduct an electrical cell at 25 degrees as follows. 1/2 cell is standard zinc cell. That is a strip of zinc immersed in 1 molar zinc. So عندنا cell and a strip of zinc solid immersed in 1 molar zinc 2+. The other is a non-standard hydrogen electrode in which a platinum electrode is immersed in a solution of hydrogen ions and gaseous hydrogen bubbling through it at a pressure 1 atmosphere. Mean to the right, mean to the left, I don't know. So we have a bubbler. Okay, so we have H2 gas. We have a platinum plate because معنا solid immersed in H+ solution at a pressure of 1 atmosphere. The observed cell voltage, عطونا observed cell voltage, E of the cell is 0.522. The E naught of zinc is minus 0.763. Okay. So typically is a chemical E is positive voltage. This is a negative, reduction potential negative. So indeed, it should be the oxidation half reaction. And the reduction then is the She electrode, where the E naught, E naught is 0. Still greater than this. The observed cell voltage is 0.522. Calculate the value of the reaction quotient. The overall reaction. So we have the zinc side is the cathode, is the anode, the hydrogen is the cathode or reduction half, separated by a double bond. The overall reaction is as we wrote here. Remember, and now zinc goes to zinc 2+ plus 2 electrons. That's that half reaction in the written in the oxidation. H plus goes to hydrogen gas, and that 2 should be multiplied plus 2 electrons. That's the reduction half reaction as written in the reduction form in this case. The overall reaction, we add the 2, we get this one. They gave me, sorry, E naught of the cell, E naught of the cell, مش of this reaction of the cell, with E cathode minus E at the anode. الكاثود 0 minus a negative 0.763, so شو صارت 0.763. So E naught of the cell 0.763. E of the cell, or E of the overall reaction in the cell, this is the Nernst equation. It's equal E naught of the cell minus 0.0592 and log of Q, which is in the overall reaction products divided by reactants. They want us to find this reaction quotient Q, the concentration products على reactants. And so we have E of the cell, they gave it to me, 0.522. We have E naught of the cell, or we got it. We have number of electron transferred is 2. It's 2. Number of electron transferred is 2 log of Q. So for log Q, you get the answer. That log Q, or that Q is 1.4 times 10 to the minus 8. What is Q? Q is simply products divided by reactant at any temperature. Products, zinc, pressure of hydrogen, divided by the H plus squared. Okay. I already have the concentration of zinc. I have the pressure of hydrogen. I have the Q. I can find the H plus concentration required to give me this E. وأنا فرد مرة كان فيي هون بدل ما أجيب Q دغري نحط بهاي A pressure of this hydrogen, zinc 2 plus concentration على zinc zinc solid على H plus squared. وفرد مرة مش ضروري يجيب Q لحالها يعني هي أسهل بلا anti-log of this number, whatever it is, and then put these guys in and solve for H plus. So yeah, calculation-wise, it's على calculator, you still have to go ahead, get that Q number, and then substitute. So yeah, get the Q by itself, and then solve for the H plus concentration that will give me this potential 0.522. Okay, determine the pH of the solution in the second half reaction. Once you have the H plus, the pH is minus log of H plus concentration. You can officially solve all the questions in the tutorial at this point ما عدا titration questions. So بالتالي نحن next week I will start directly in the today. Still a few more things, but I can مسألة concentration cell and ampholytes can be discussed, and then titration. And I will start with the today, solve everything till I get to titration before I continue with these parts as well as the titration. Titration is very, 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 very easy. Okay, very easy. منا مثل acid base. It's much, much easier.